Welcome back to Nature of Code in Rust and GGEZ. Today we're going to be going over exercise 1.7. We're going to be translating the following pseudocode to code using static or non-static functions, which looks to me like almost all of them are going to be the static functions. Okay, so we need to set a p vector and set it equal to 1 and 5. Have our vector, create another vector, and have it be the previous vector multiplied by 2, so the scalar. Then create a third vector and have it be the second minus the first vector, or the first minus the second vector, and then divide that last vector by 3. So that feels like a lot of methods we're going to do. And so I'm going to actually do this in a test inside of the vector class. So in vector down here, let's just go to the bottom and we'll create our config test. And I can actually, maybe I'll just create this exercise 1.7 here. We can use super. Then we'll have a test. And I guess we want to do this all in one function as it were. So maybe we will just call this tests. So we'll call this function exercise 1.7. All right, so the idea of the pseudocode. Let's actually take this entire thing, we're going to copy it and put it in, we can actually document this. So there, translate, okay, the following pseudocode. All right, so we need to first start with the p vector v equals 1.5. So let v equals a vector 2, 0, 5.0. Kind of need to have a new keyword in there. Okay, so we created that. Now we need to create a vector 0, u equals v multiplied by 2. Now if we use the multiply scalar that we have right now, it's unfortunately going to create, it's going to mutate v, and we don't want that to. So we have to create a new method up here. So let's do it below random because everything else is internal. So this is pub function. We can have multiply scalar. I've never tried having a function with the same name but different method signatures. So I'm sort of curious whether or not this will work. Then down here, oh, now it's saying we can't have this. We have duplicate definitions. So we need to rename this. What should we call this? We have like multiply scalar down there. Maybe static multiply. Multiply scalar static maybe. And then we're going to have our scalar, which is an F32. Then how is this going to be coded? We're going to say we're going to take. Oh, this is both of them. So like scalar 1. Oh, right. Never mind. We have a scalar, and then we have the vector that we care about. Yes, that's what it is. So we have a new vector that's created. So maybe we have a vector 2, which is a type self, and then a scalar coming in, and we're going to return, we're going to create a vector. We're going to clone it off of here. So vector2 equals vector2. This is probably going to have to be a reference to this. So I'm going to dereference out of here to force a clone. It's mutable here, so now I can scale that up. So vector2 dot multiply scalar, pass it in a scalar, and then we're going to return the new vector2. So if I wanted to write the documentation for this, or the actual like test to make sure that this is doing exactly what we want, so take in a vector2 and a scalar, multiply them together, and turn a new scalar, new vector. All right, so we need this use. And let's create a little scenario here. If we wanted maybe to create, it could be like this v. So we could just set v equals new vector2. We're going to set you to 1 and 5, 1, 0, 5.0. And then we want to have u by multiplying it by 2. Okay, so then we want u equals v dot multiply scalar static and pass it in the v, a reference to v, and u. Now I could clone it also at this point in time. I don't doesn't have to be like, because self clones, I could just do this, but it's not explicit, I don't believe. I would want, can I be explicit with a clone there? Using clone on a copy type. I guess that will auto clone. And we can ensure that with some testing here. So, okay, we do this, yeah, u equals the multiply scalar static. Okay, so we can do some assertions here. So we can assert equal, v should still be equal to a new vector2 between 1.0 and 5.0. And year 2. And then assert equal that u should now be a vector to new of, let's see, if I multiply by 2, you should be 2.0 and 10.0. And if we run this, no method named multiply scalar static in the current scope. Could you not find it? That is that. What are you upset about? Oh, it's vector 2. Colon. That's what we need to do. Let's try this again. There we go. Okay, so that passes that test. So then we can come back down to here. So now that we know that it's working correctly, all right, so we have v equals this, then u is going to be equal to v multiplied by 2. So let u to vector 2 multiply scalar static, pass it in v, pass it in 2.0. All right, then the vector w equals v minus u. So it sounds like we need another subtract. So it's going to be the same thing. Okay, so here's random. Here's the multiply scalar static. And I think this is going to be very similar. I'm just going to copy this and we're going to update it. So take in a vector 2, take in 2 vector 2s, right? Yeah. Take in 2 vector 2s. Subtract them and return a new vector 2 as the result. All right, so we're going to use this. We're going to create v and u is just 2 completely different vectors. So new, and let's do maybe 1.0, 2.0. Then we're going to subtract them so that this is w equals v vector 2 subtract static then v and u. Then we're going to assert that v is the same. U should be the same as this. Should not be mutated. 0, 1, 2. And then assert equal. W is going to be a new vector 2. That's going to be them subtracted together. So I expect this to be 0.0 and 3.0. Of course, if I were to run this, I don't think it's going to work properly because they're not set up to be what they expect to be. What are you yelling about? I finished writing all this code fine. Oh, duplicate definitions, correct. Going to be a subtract static. We're going to take a vector, vector 2a and a vector 2b. We're going to return a new self. Okay, so we're going to have a let mute vector 2 equals. So how do we want to do this? I think it's actually just going to be easier for us to return a new self with the x being vector 2a dot x minus vector 2 vector 2b dot x y, which is a vector 2a dot y minus a vector 2b dot y. So this should work. All right, passed. Let's go ahead down here and continue on. Okay, so now we can have that w equals our v, which is vector 2 minus subtract static v and u. And then finally, divide the p vector w by 3. Divide the p vector w by 3. So if I wanted to do something like you need to be mutable, and then we want probably like a divide scalar, which is very similar to this multiply scalar. So we're going to say divide the x and y values of the vector by the scalar. This will scale up or down. That is still true. So we're going to create a new vector 2. We're going to have you be a divide scalar. If I have it by 2, let's see. If I divide, let's have you be 2 and 4. So if I divide you by that, we expect you to be 1 and you to be 2. And taking you in, you're going to be just divide equals. So you should now pass this. You do, perfect. Which means we can run u. So let w dot divide scalar by 3.0. And that's it. Now it doesn't have here like what this answer exactly would be, and we could figure it out. All right, what are you upset about? We want you to be a u, not a w. Okay. And so this should work. We can run this test. We don't actually check anything. We could figure that out. But before I go, I want to actually show a much, much better way. Like the Rust makes this so much better. And any of you who know Rust is probably thinking like, why are you doing this? Like, why did you like create all of this like static stuff? It's not necessary. Wouldn't it be better if we can write this in a much different way? So we create V like this, that's fine. But if we want to multiply these together to create a brand new thing, well, multiply scalar static, that's actually not as easy, so that we may need to do that. But this subtract, we can do this better. What if instead of the static, what if we want v minus u? So we just said v minus u. We should be able to do this ourselves. This is just yelling at us saying we can't subtract these two vectors. What I'm going to do is I'm going to come up here to our subtract static, and I'm just going to delete it. We don't need this. Instead, we're going to implement a new, very similar trait to this. So impl sub for vector 2. Okay, so type output is going to be equal to self. We're going to return a self. Our right-hand side is going to be, okay, it brings in a self, outputs that. So we're going to say a self with the x being self.x minus right-hand side dot x. Y is self.y minus right-hand side dot y. And that's it. That should do exactly the same thing. If we run, we could like write the documentation to like test this out. And I deleted that, didn't I? That was unfortunate. We could rewrite that really quickly, but it's going to be the exact same thing. We're going to take the left-hand side, which is self, and the right-hand side, and it should just work for us. Everything should still work now. And all right, I know it's not really a true test, but it should be showing what this exercise looks like and how to properly do this math on here. I haven't figured out a better name for this multiply scalar static. If I do think of one, I will definitely update it for in future episodes. With that, this is exercise 1.7. I hope to see you in the next video. Have a great night. Bye.